Okay, now the next is PN junction formation. Next one is PN junction formation. Okay, now let's see what's there in your PN junction. See, in PN, what we are doing, we are having a P type and N type, and we are just, this is a high-end engineering process. We are just connecting the P type and N type semiconductor. Okay. This is P type. This is N type semiconductor. This is P type semiconductor. Okay. Okay. This is P type, and this is N type. Okay. From P till N. We are connecting a battery also. If yeah, if we can remove. See, this is your PN type, P type, and if there will be a P type semiconductor and an N type semiconductor, if you are keeping it at like this, then what will happen? The positive from this side and negative from this side will get neutralized, and there will be a region at which this electron and holes will make a pair, and that will sit, and that region is known as depletion region. I'm repeating, just to see here. Okay. Yes, we have p-n junction. When they are brought together, the positive will get neutralized by negative. And the region between p-type and n-type is known as, it is known as depletion region. Okay, that is known as depletion region. Now, see, imagine a thin semiconductor wafer made of p-type silicon. A portion of P silicon wafer can be changed to N silicon by adding an exact amount of pentavalent impurity. There are multiple methods by which a semiconductor can be created. There is now P and region on the wafer along with the metallurgical junction connecting them. Diffusion and drift are the two crucial steps in the creating of the p-n junction. We are aware that the concentration of electron in an n-type semiconductor is higher than the concentration of hole. Like this, A p-type semiconductor has a higher concentration of hole than the electron. Owing to the concentration gradient that exists between p and n side during the creation of p-n junction, hole diffuse from p side and n side, as well as electron diffuse from n side to p side. Likewise, when a hole disperses across similarly, an immobile ionized acceptor is left behind when a hole diffuses from P to N because of the concentration gradient. A layer of negative charge, a layer of negative charge, also known as negative space charge area, develops on P side of the junction as the hole continue to diffuse. Because the electron and holes involved in the initial movement across the junction drain the region of their free charges, this space charge zone on either side of the junction is collectively known as depletion region. Very important definition it is. Huh? The depletion region has a thickness of about 10th of the micrometer and electric field directed from positive charge towards the negative charge. Because of the positive space charge area on the N side of junction and the negative space charge region on the P side of the junction. This field causes a hole on the N side of the junction to move to the P side of an electron on the P side to go on the N side. See, without applying battery, if there will be a flow of current, then that current is known as drift current. Okay, so drift current is initially minimal and diffusion current is considerable. Drift current is minimal and diffusion current is considerable. The space charge area on either side of the junction expand as the diffusion process goes on, strengthening the electric field and subsequently the drift current. Until the diffusion current and drift current are equal, the process keeps on. This leads to a creation of p-n junction. There is no net current in an equilibrium p-n junction. A potential difference exists across the junction of the two regions because of the n region electron loss and p region electron gain. The potential are polarized in a way that it prevents additional carrier flow, maintaining the equilibrium. The potential across the p-n junction and the junction at equilibrium are shown in the figure. Let's see the question based on this. The question is, during the formation of p-n junction, options are diffusion current keeps increasing, drift current remains constant, both the diffusion current and drift current remain constant, diffusion current remain almost constant, but the drift current increases till both current becomes equal. Options are diffusion current keeps increasing, drift current remain constant, both the diffusion current and drift current remain constant, diffusion current remain almost constant, but drift current increases till both current become equal. during the formation of p-n junction? Options are: the right answer is, during the formation of p-n junction, diffusion current remain constant, but diffusion current increase until the both current become equal. Correct option is option D. Okay. When a p-n junction is reverse biased, what happens?